Hello, what is a graph? In this video we are going to define what we mean by a graph and discuss the definition of direct and indirect graphs. Also we will discuss how we can model a graph. Finally we will illustrate some examples of a graph's applications. A graph G consists of V, an empty set of vertices, or we can call them nodes, and E is a set of edges or path. Each edge has either one or two vertices associated with it, called its endpoints. An edge is said to connect its endpoints. The set of vertices V of a graph G may be infinite. A graph with an infinite vertex set or an infinite number of edges is called an infinite graph. A graph with a finite vertex set and a finite edge is called a finite graph. We will usually consider only finite graphs in this course. So let us take a definition first. In simple graph, each edge connects two different vertices and no two edges connect the same pair of vertices. Multigraphs have multiple edges connecting the same two vertices. When M different edges connect the vertices U and V, we say that U and V is an edge of multiplicity M. An edge that connects a vertex to itself is called a loop. A pseudograph may include loops as well as multigraph edges connecting the same pair of vertices. Now, what is the formal definition of direct graphs? A direct graph or a digraph G consists of an empty set V of vertices or nodes and a set of E of directed edges or arcs. Each edge is associated with an ordered pair of vertices. The direct edge associated with the ordered pair U and V is said to start at U and end at V. A simple directed graph has no loops and no multiple edges. This is a directed graph with the 3 vertices and 4 edges. A directed multigraph may have multiple directed edges when there are M directed edges from the vertex U to the vertex V. We say that U and V is an edge of multiplicity M. So in the example, in this directed multigraph, the multiplicity of A and B is 1, and the multiplicity of B and C is 2. When we build a graph model, we use the appropriate type of graph to capture the important features of the application. We illustrate this process using graph models of different types of computer networks. In all these graphs models, the vertices represent data centers and the edges represent communication links. To model a computer network where we are only concerned whether the two data centers are connected by a communication link, we use a simple graph in this case. This is the appropriate type of graph when we only care whether two data centers are directly linked and not how many links there may be between them, and all communications link work in both directions. To model a computer network where we care about the number of links between data centers, we use multigraph, as we see in the figure. To model a computer network where we have a diagnosis link at data center, we use a pseudograph as loops are needed in this case. To model a network with multiple one-way link, we use directed graph. Note that we should use a directed graph without multiple edges if we only care whether there is at least one link from a data center to another data center. To understand the structure of a graph and build a graph model, we ask these questions. Are the edges of the graph undirected or directed? In the edges are directed or multiple edges present that cannot be the same pair of vertices. The edges are directed or multiple directed edges present. Are there a loop present in the graph? And the table is showing in the slides are giving you a summary of those graph terminology. We illustrate how graph theory can be used in models of social networks, communication networks, information networks, etc. It is a challenge to find a subject to which graph theory has not yet been applied, and you find an area without applications of graph theory. We can use a simple graph to represent whether two people know each other, that is, whether they are friends in real world or in Facebook. Each person in a particular group of people is represented by a vertex. An undirected edge is used to connect two people when these people know each other. When we are concerned only with the friendship relationship or whether they are friends. No multiple edges and usually no loops are used. If we want to consider or to include the notion of self-knowledge, we would have to use loops in this case. A simple friendship graph is shown in figure 6. The friendship graph of all people in the world has more than 6 billion vertices and probably more than 1 trillion edges. So the figure is giving you an example of social network graph where we have, for example, Jane is connected to Paula and maybe also Liz is connected to Amy and so on.